Hello everyone, welcome to our presentation on using customized BERTs for sentiment analysis of Tamil political comments. I'm Sabrina Afroz Mitu and I had the pleasure of working with Enjamamul Haque Eram, Anisha Ahmed and Azmine Toushik Wasi. Let's dive into how we approached the unique challenges of sentiment analysis in the Tamil political landscape. The challenge of Tamil political sentiment analysis in social media. Why Tamil? Tamil is one of the oldest, richest languages in the world, yet it remains underrepresented in NLP research, with political discourse rapidly evolving on platforms like X, formerly known as Twitter. There's a growing need to decode public opinion in Tamil. However, existing models struggle with its complex morphology, dialectical variations, and especially sarcasm and ambiguity. This is the gap we aim to fill. Eureka-CIOL 2025 focus. Our research focuses on the fine-grained multi-class sentiment classification, dividing Tamil political tweets into 7 distinct categories. Unlike binary or ternary classification, this approach offers deeper insights into the socio-political climate and public emotion. We aim to create a framework that is robust, adaptable, and capable of navigating the nuanced landscape of Tamil political conversation. To achieve our goal, we designed a framework with 4 key objectives. First, we customized and fine-tuned a BERT model specifically for Tamil. Second, we performed extensive hyperparameter tuning, keeping low resource constraints in mind. Third, we contributed an annotated dataset of political tweets labeled across 7 sentiments. And finally, we benchmarked our model to set new baselines for political sentiment analysis in low resource settings. Our dataset consists of Tamil political tweets, annotated into 7 classes: substantiated, sarcastic, opinionated, positive, negative, neutral, and none. But this wasn't without challenges. Class imbalance was significant, with sarcastic and substantiated tweets being notably fewer. Combined with the inherent ambiguity in political speech, this made training both exciting and difficult. Here's a look at our architecture. We used a pipeline of tokenization followed by a fine-tuned multilingual BERT. Specifically, the Cardiff NLP BERT-based multilingual cased sentiment multilingual model, layered with dropout and a classification head. Fine-tuning was done using Hugging Face and Tweet NLP. This architecture allowed us to balance performance and computational feasibility. Our training setup involved batch sizes of 32, a learning rate of 0.001 and up to 50 epochs. Dropout ranged from 0.3 to 0.4, with hidden layer sizes scaling up to 1536 dimensions. On training, we achieved an impressive 79.8% accuracy and 80% F1 score. However, the validation and test scores reflect the real challenge: class imbalance with a macro F1 of 0.3187. Still, this performance ranked us 4th in the official task leaderboard. A few important learnings emerged. First, larger models like those with 1536 hidden units tend to generalize better. Second, a dropout rate of 0.3 proved optimal, effectively preventing overfitting. And finally, hyperparameter tuning played a critical role in low resource NLP. Interestingly, despite domain mismatch, our multilingual BERT model adapted well, highlighting its potential. Every model has its limits. Ours struggled with domain mismatch. BERT wasn't pre-trained on Tamil political data. Sarcasm and class imbalance reduced performance on minority categories. And with limited computing power, scaling the model further wasn't feasible. That said, ranking 4th shows how powerful even a fine-tuned multilingual model can be when customized strategically. To summarize, we ranked 4th in the Eureka-CIOL at the DravidianLangTech 2025 sentiment task with a macro F1 of 0.3187, outperforming the task mean and median. This validates the effectiveness of our approach. Looking ahead, we plan to pre-train BERT further on Tamil political corpora and extend this work to other Dravidian languages, opening new doors for multilingual political sentiment analysis. In conclusion, our study proves that with careful model design, targeted fine-tuning, and a deep understanding of linguistic nuance, it's possible to advance sentiment analysis in low-resource and politically complex settings. Thank you for all your attention, and this is the last of the presentation.